Welcome, everyone. Wow, haven't seen so many of you in a while, but we're back. We're fully on Blockchain NYC. Yeah, we're hosting events, occasionally live, occasionally like this online, and I'm thrilled to moderate an incredible panel today. So the team is super solid. I've been in blockchain for over 7 years, and I love when there are teams that come up with some really cool ideas, cool projects, especially when they innovate in a space that sometimes seems already so innovative, but also a lot of ideas kind of copy each other. So I find that found that IronWeave is really making a difference in how they're imagining the future for us, the future of blockchain or Web3 of connectivity. So we have a fireside chat today with the founders of the team. So I'm thrilled to see you all here, founders as well as the audiences. And without further ado, let me introduce you one by one. First of all, have you guys heard about books for dummies? It's when somebody really, really bright distills something to really simple terms. So David actually wrote one of the books in series for dummies. So pretty awesome. And he's also written many other books. So like from dummies to the experts, right? To the hackers to the data scientists, you name it. He also have taught his courses were taught across hundreds of institutions to tens of thousands of students. In addition, he spent many years in Microsoft, and I will let him in, and he'll give us a slightly longer introduction. David, please.
All right, hello. Thanks for having me. I'm glad to be here.
Yeah, absolutely. Now, next person in line that is the CTO of IronWeave is Kelly Burr, and he is an incredible mind who really puts some incredibly difficult technical decisions to life. So he have worked with some of the largest companies in the space. He have run very large development teams. So we're thrilled to have him because I can't wait to see what is behind IronWeave, what is going to be the next wave. So Kelly, please join us.
Thank you, Art. It's very exciting.
Oh yeah. Like I said, the projects like that where it's something so different that it adds a lot of value to the space is really special. And next we have Team. So Team has a background in finance. He's a really sharp guy with the numbers on his mind, and he really rounds up the team in IronWeave so well, operationally and financially. And so let's without further ado, let's bring him out.
Thank you, Art.
All right. Well, let's just jump right in. So we have a whole presentation ready for you that is going to cover a whole lot of the stuff. So let's start with a simple question that on everybody's mind. What is IronWeave?
Sure. So I can start with kind of an overview of what IronWeave is and how it differs from all other blockchains out there. And then Kelly can talk some more of the details because Kelly is the one who brought this idea to life. So IronWeave is a multi-dimensional blockchain fabric. So what does that mean? Where other blockchains are what we call monolithics, where you have one block placed on top of the other with a hash from the previous block included in that block to provide a sort of thumbprint. That is a serial block fashion where there's one block on top of the other and only one at a time. In IronWeave, there's no limit to the number of interacting blockchains you can have. And in IronWeave, when an interaction occurs, only the participants' chains are included in that particular interaction. So you could have chains A and B over here engaging in an interaction where a block is created and placed only on their chains. And simultaneously and in parallel, you could have three other chains over here having an interaction where a block is created and placed on each of their chains. We call this technology shared block architecture. And importantly, there's no single chain to which all interactions have to reconcile. So you get parallel block creation on IronWeave. So Kelly, maybe you can talk a little bit more about how that all works.
Yeah, I'd love to. So when we took a look at traditional blockchain architecture, there were a couple of challenges when it came to privacy and scale. And that's really the two big things that we're focusing on addressing with IronWeave, kind of over what else is going on in the Web3 space, is the privacy and scale capabilities. And so when we came up with the shared block architecture, the idea was, rather than using, and I may get a little bit technical here, rather than creating just a singly linked list of one long chain and a single state machine where everything always has to be in sync and the entire network has to agree and pack as many transactions as they can into one block, we realized we can get far higher block yields, have a lot better privacy, and overall unlimited horizontal scale if we used a heap structure instead, where we basically just throw all the blocks right into this fabric. And we use a chain synonymously with how Ethereum, for example, would use address. And so every address, every participant has their own chain of blocks. And every block that interacts between two chains, where it's someone sending currency to another, or a data exchange between two apps, or an interaction with a contract, involves just these participants, just these addresses, just these chains. And so the prior block references go in multiple directions. And so this is why we call it a fabric, or, hence the term the iron weave, is we are weaving together through these interactions multiple chains and multiple independent state machines that only periodically synchronize and then can diverge. And this allows us to have parallel and simultaneous block creation across thousands, millions or more different chains with no impact to each other, giving us the first real Web3 blockchain solution that actually has unlimited horizontal scale, where as opposed to current solutions out there that get more expensive to operate and get slower the more and more people you have participating in the network. The larger our network grows, the faster and the faster it gets, and the more predictable the costs get, the faster in aggregate everything gets.
And maybe it might help to talk a little bit about where this idea came from. So I spent 20 plus years at Microsoft in the core operating system division and some other divisions like the AI division and data. And one of the things that I saw throughout my time at Microsoft was the need for scale. So a business isn't going to bet its future or put its data into something that doesn't scale or gets more expensive the more other people use it, and frankly that isn't private or secure. And that describes pretty much all other monolithic blockchains. So when I was there, I saw a couple of problems that would have to be solved before blockchains could really take hold. And I saw a lot of different pretty disruptive technologies while I was at Microsoft. And when blockchain came around, I said, this has the potential to be as disruptive as cloud computing or internet connectivity, but it wouldn't get there if there weren't scale and weren't privacy. Based on my experience in the operating system environment and in data and protocols and the like, one day, literally, I was on my mower trying to figure out, okay, how could you get a blockchain to scale? How could you get it to where an enterprise could use it, and so that the traction that the world believes, all these solutions and creative things that blockchain could solve, all assume scale, all assume security, all assume privacy. So I was out on my mower, and that's when shared block architecture came to me. Don't focus on the chain, where you have a bunch of different people's transactions all blocked into one block. Think about it on the block level, where each block can be a private interaction, so that only the people who are participating need to or can see that. And then from there, it kind of blossomed out to, well, then you could have an unlimited number of chains, and every single interaction could be private and secure. And one of the ways that we get there is Kelly's innovation about this just unique mechanism by which each block is encrypted with its own set of keys, making it private to those participants or shareable if one of those participants chooses to do so. So Kelly, you want to say that, kind of explain how you managed to make that all work?
Yeah, so there was a question that was posted here in the comments about asking what a heap was, and I kind of threw that term out. Let me answer that real quick. Basically, what it means is all the blocks can coexist in the network without having to know anything about each other. They can all just be piled in, and again, each block references the prior block from each chain that it's participating in, but doesn't have to know anything about any of the others. And so it's just, in computer science, without going too technical into this, there's lots of different data structures, but a heap is the fastest one to throw information into because you don't have to reorganize anything else to add into a heap, and it allows a lot of different values to kind of sit there in parallel. But to go back to what David was saying here, because of the shared block architecture and what we've come up with, we realized we had an opportunity to add some real first-class features into our blockchain that it's not that they can't be done in others, but they require a lot of effort on the part of the developers to do, or their afterthoughts. And that's things like end-to-end encryption, multi-sig, to have multiple signatures for verification, things of that nature. And so the encryption was a big one we jumped onto to add. Not only do we have the privacy of not everyone seeing every block and not having a single chain that anyone can just process through, but we can encrypt these payloads within the blocks end to end through the use of PKI. So and that's public key cryptography. And that's what all e-commerce and secure communication on the internet is based on. And so we're using similar concepts as a first-class feature where there is a unique payload key generated for every payload in every block. And then along with those prior block references, there is an encrypted copy of that key encrypted with the public keys of each participant. So you don't have just your signing keys. When you generate something like, and again, I go back and I reference, I'll do a little bit of comparison against Ethereum just because it's kind of the big boy, right? It's considered mainnet by so many people. So it's easy to run the comparison. So with Ethereum, you have your address and you have your public and private key, and your private key is used for signing, for initiating transactions, for proving authorship of your transaction and intent. And then transactions can be verified through the use of the public keys. Well, we have the same public and private keys we use for signing and proving authorship of blocks in similar mechanisms to what everyone else does. But we also have public-private encryption keys that the owner of a chain can rotate whenever they want. And those are published in a global registry and they're available on chain. And so if I'm going to send information from myself to someone else and I want to end-to-end encrypt that, there are built-in structures within the IronWeave to enable, and within our SDKs to enable end-to-end encryption, where I can encrypt that data with a unique, strong encryption key and then make that key available only to those participants through the use of those public keys. And all of this information is written on chain.
So that brings me to the next question. So does let's say somebody who wants to build in the future on IronWeave, do they need to know, is there a specialized programming language that needs to be used, or how does it all operates? Yeah.
No, so the vast majority of your interactions with IronWeave, especially for people that want to do, say, Web 2.5 stuff, integrate off-chain applications with IronWeave, integrate mobile apps with IronWeave to build wallets, or for financial products and transactions. A lot of my background is in the world of traditional finance, Fortune 50 and Fortune 100 financial services. And so to integrate these systems into IronWeave, it's simply APIs. So the APIs are based on gRPC, which is available in almost every popular programming language has a port of gRPC. It's completely open source. Major contributors to it are Google and Microsoft. And it's used in some of the most popular internet technologies and cloud native technologies. And so for integrating your apps with IronWeave, again, whether it's a mobile app, if you have a game that you want to have on-chain transactions, or if you're building a wallet app, or one of our first-party apps, our encrypted chat application, it all communicates with IronWeave just through the use of gRPC APIs. And then some SDK layers we're working on to make that even easier on top of that. Then for on-chain applications, when you start talking about dApps and smart contracts, the smart contract here we're working with is a WebAssembly runtime. And so that allows you to build in any language that can compile to WebAssembly. Rust will be a very popular choice, as will, JavaScript, TypeScript, C#. I believe there's a good WebAssembly compiler for Go now. So lots of various languages. So we have not, we're not trying to, while we endeavor to make it very easy to port things like an EVM DApp over to IronWeave, we're not trying to reproduce specialty blockchain programming languages. We're trying to make this a lot more accessible and available for developers using their favorite open source tools, languages, etc., that can use very industry standard gRPC APIs for off-chain, or can compile to WebAssembly for on-chain.
Yeah.
So yeah,
if I can quickly add on to that, Art,
please,
just
please.
quickly. So a couple of kind of key takeaways from that is, so the vast majority of developers out there are familiar with these kind of common everyday programming languages, and they may not be interested in learning Solidity or some of the others, so that any industry that is using programming has a low friction means by which they can start developing and taking advantage of IronWeave. And the parallel block creation that Kelly was describing, just to provide some context on that, with data on chain in a single managed node, we're seeing over 1 million interactions per second, with block creation times in the milliseconds. So, and also, because there's parallel block creation, every time you add a managed node, you add to that. You add to the capacity and the scalability. So just like when you add another data center to the internet, when you add another manager node to IronWeave, you increase its capacity and its throughput. So Art, go ahead, sorry.
Yeah, no, this is exactly, it's so different and yet so needed. So and I think the next question is like, that leads me to the next question. What does IronWeave do that isn't actually and currently being done, or cannot be done either by L1s or other data structures?
So I'll start by saying by kind of going back to what Kelly mentioned, which is each interaction on IronWeave is inherently private and inherently secure, and the data is in the block itself. So if you're sending a message, if you have an NFT that you want to create and then share with the world and get royalties on, the actual data of that interaction is on chain. And you can have 100 chains, you can have 1,000 chains, you can have, just like you have different bank accounts, et cetera, you can have a chain for your insurance, you can have a chain for your crypto, you can have a chain for your car that happens to be doing all sorts of different things. The applications are unlimited because the block size in IronWeave, because there's no central chain to which it needs to reconcile, is flexible. You can do small little IoT updates. You can have a contract that has been e-signed by the counterparties. You can have an MRI. You can move crypto. There's all sorts of different applications, and it's real. Or you can have an infrastructure, like if you're a Colonial Pipeline and don't want to get hacked, you can have your critical infrastructure on IronWeave and take advantage of the security, privacy, immutability, and all of those other sorts of things that only IronWeave can do. So it's that inherent privacy and security. It's the flexibility of any block type, and the fact that these interactions are only visible and accessible to the participants.
So Kelly, can you tell us a little more like how each block is encrypted with, I believe, its own set of keys?
Yeah.
So
I would be happy to. So when using the end-to-end, so first of all, the network itself is always encrypted. So all the communication is TLS encrypted. All the data is encrypted. So whether or not the applications or the interactions choose to use the built-in end-to-end encryption feature, all the data is encrypted anyway. But they can add a double layer of encryption that actually makes the contents of the block invisible to the IronWeave network itself, so it's completely opaque. So even the node operators don't get to see those end-to-end encrypted blocks. No one can read the contents of these, making it completely secure and private. And the way that mechanism works is the client that's creating the block has the payload. It doesn't send the unencrypted payload into the network. It encrypts it generates a new key. Now, all of our encryption algorithms are pluggable, so they can be upgraded to handle things like post-quantum. But right now, the defaults for these would be they would generate a new AES 256 key to encrypt the payload, generate that key, encrypt the payload with the key. Then they retrieve the RSA 4096 public keys of the other chains that they want in on this interaction. And they use those public keys to encrypt the session key, the payload key. And those all get stored within the metadata of that block, within the actual block data, along with those chain IDs and those last block references. And so that block then gets written on the chain. Of course, then it's signed with my private signing key. So we can prove authorship of it through the use of private signing keys, just like you do with that. And because we have multi-sig, the nodes, the validators that validated these transactions also apply their signature to it from their key. So we know exactly who is signing this. And this goes partly into the consensus and proof mechanism that we use. But then for the readers inside these, if I own one of these chains where I'm an interacting member on this block, the data's been sent to me, I can go ahead and retrieve that block because that block is on my chain. But if anyone else retrieved it, they wouldn't be able to look at the payload anyway, because unless they know the private encryption key of one of the parties to that chain, like mine, I can then, since I have that private encryption key, I can decrypt the payload key directly, which then allows me to decrypt the payload. And these mechanisms are similar to how all secure transactions work on the internet. We're using some of the same mechanisms. And again, we've chosen common open industry standard technologies that we've combined in a novel way. And you know, we've built our technology on the backs of technology that will be very, very familiar to developers, from open source hobbyists to enterprises, that, you know, security companies and professional internet security audits are very familiar with these, and that the, you know, major security firms recognize to be industry best practice.
Excellent. So what about, I got a follow-up question here. Can encryption for a block created today be upgraded to stronger encryption method in the future? And our blocks are future-proof? Yes.
So blocks themselves, once a block is encrypted, because the nature of blockchain, the block hash is part of the last change. So upgrades would be block forward. So you wouldn't necessarily go back and re-encrypt an existing block with stronger encryption. So we'll obviously be encouraging, we're already having great discussions with some of the future encryption vendors that are designing post-quantum encryption. And we'll be encouraging a move to that as soon as it's more readily available to the public, and because those standards are being set now. So no, unfortunately, the nature of blockchains means you really can't go back and re-encrypt an existing block. Once a block is written, it is immutable.
Excellent. So next question. So this is obviously interesting to everybody here, and which is which stage are for investment is IronWeave, and why should investors be excited about IronWeave? What makes it so special? And maybe we'll start with Tim. Like maybe let us know, Tim. What do you think?
Well, Dave and Kelly just highlighted some of the things that make IronWeave very different from other solutions out there, whether in the blockchain or crypto world or in the traditional computation world. Some of the things that IronWeave enables are things which you just can't achieve using the existing systems, and it unlocks value which has been untapped heretofore. So let's just take a look at the crypto ecosystem and view it from that ecosystem's perspective. There's a lot of talk of migrating traditional finance activities on chain. You hear about real world assets all the time. And I have believed since 2015 that would be the future. However, the blockchains that we're all familiar with today, they don't enable the replacement of the existing systems that we have in the traditional world, and they don't yet enable some of the activities which are of most value to people in the traditional finance system. So what we're enabling here is the ability for a decentralized platform to enable multiple parties to interact with whomever they want, whenever they want, in a private and secure way, with all of the transactions being immutable. So Therefore, you're finally able to eliminate a lot of the operational expense that has been plaguing traditional financial institutions since the beginning of them. You're also able to take this trust, which we've had to place in some of our institutions, which has been misplaced quite often, and to then basically have that trust decentralized over a network, which is much more difficult to compromise. And then also allows for these parties to interact with each other in a way where only the people that are participating in a particular transaction have eyes on that transaction. So it opens up cost savings, it makes things more expedient, it allows people to trust the network and the people that we're working with a bit more readily, and it also enables the unlocking of value across many different asset classes. So even just the financial industry alone unlocks a tremendous amount of potential through IronWeave. And I think there are many other applications for this as well.
Excellent. And maybe Kelly, you can give us through perspective from tech. Why would investors be interested in why is tech so different from others?
Mm-hmm. Well, first off, I will say that the use cases Tim just talked about are some really exciting ones, and those are ones that really got me so interested in this project early on, with a background in big finance and years and years, 20 years, 20 years in enterprise finance, almost in those areas. It was really apparent. And this goes into kind of the use case, say that the move to Web3 and the move to blockchain has done a lot of great things as far as decentralization and reducing the need for trust, right? Trustless but it has left behind an element of scale and an element of privacy has just been left behind. That was abandoned with Web 2, and I firmly believe that should not have been abandoned. And so what we're striving to do with IronWeave, and where I think we're really exciting, is we bring those capabilities that most of Web3 left behind, but that are critical to whether it's traditional finance institutes or high volume Web2 companies, again, games, auction houses, et cetera, that are looking for high volume, that are looking for transaction privacy, e-commerce scenarios. Most e-commerce isn't feasible on most current blockchains, just strictly because of volume and privacy requirements, the ability to handle the transaction as well as the metadata to keep the information both secure. The trustless is great, but also secret. The tokenization of real world assets, real estate transactions, things of this nature. People are getting more concerned with privacy. Institutions are very concerned with privacy. And while they love the permanent records retention of Web3, bringing some of these capabilities back. The other thing is, because we're not using anything like proof of work, we do have hashing in our network, but high hash rates do nothing for you. Our consensus mechanism rewards high availability and reliability, as well as the staking. And so we can take advantage of the huge surplus of Web 2 hardware. There was an article yesterday that Microsoft is investing $50 billion a year in data center infrastructure. This outpaces most government spending projects, right? And that's just Microsoft. That's not to say Amazon and Google and Rackspace and Oracle and IBM and all of these guys. And very, very little of this, hundreds of billions of dollars a year going into data center is actually built for Web3 optimized infrastructure, but we're designed to take advantage of this kind of infrastructure.
Wow, it's a real shift. And David, maybe tell us back to that same question, as what is the vision? Kind of uniting it all. I would love to hear that.
Sure. So as I mentioned earlier, I'm a firm believer that blockchain is going to be one of the most disruptive technologies. And when we look back on it, once it reaches more mainstream, we're going to say, how did we ever operate before? Because it has this promise of being able to have data be immutable and secure. But the vision for IronWeave and how it differs from where things are in the blockchain Web3 world right now is global scale, so the ability for horizontal scalability, and anyone who wants to use the IronWeave fabric for their business can do so without concern for high prices or a lack of availability of resources.
Mm-hmm.
Security, so their data is secure, and if they don't want to share it with others, or don't want, if it's a traditional finance entity that doesn't want to be front run because their blocks are visible on Etherscan, you can use IronWeave. And then privacy. There's all sorts of reasons why these breaches occur today that we see, every week and sometimes every day. In today's data structures, one breach can give you just a colossal lake of data that you can then mine and use and actually re-encrypt and prevent the owners from getting back at it. This is traditional ransomware. So the fact that shared block architecture operates on an individual block that is uniquely encrypted with its own set of keys, instead of these big data lakes where one breach gets access to all, in IronWeave, every single block is like a little safe deposit box that has its own set of keys thrown into this ocean of hundreds of billions of others. So for any hacker to try to get to a given block in IronWeave, it would be like trying to pull a piece of rebar out of a skyscraper's footing. You'd have to find it, you'd have to crack it, and then once you cracked it, what would you do with it? You couldn't change it because it's immutable. So the vision is that in this online world that we live in, that continues to expand in terms of the sorts of things that we put onto the internet, the previous kind of data structures, these data lakes, these databases that are always connected and always under attack and under siege, provide this one gateway for people to get into and then grab a whole bunch of data. With IronWeave, it's designed and built for an online world where each interaction is private and secure instead of everybody's interactions being in this big lake. So the vision is a world where our online interactions are secure and private, where we can have a holistic platform like the internet, but a private environment like nothing that's been seen before, and a world that then can grow with business, exchange digital currency, get real world assets onto IronWeave, and be able to trade them in a way that is, again, secure, private, and knocks out the middleman, but provides you with ownership and control over your own data.
Fantastic.
Yeah. One other point I'll bring up. So we've touched upon it a number of times. It's the privacy that comes from our architecture versus, let's say, what you can achieve with a monolithic chain. If you have an Ethereum address or a dozen Ethereum addresses, which probably we all have, it's pointing at the Ethereum ledger. So we have addresses, but all that information is right there on the public ledger, one ledger. In IronWeave, you also have addresses, but each of these addresses is for individual chains, which individuals control just as they would an Ethereum address. But each one of these chains is comprised of its own unique series of blocks based on the interactions that the owner of that chain has engaged in with other chains in the system. And it's through this hash graph that's created, as Kelly described earlier, where each block has its own hash that is basically derived from the hashes on the last blocks of the chains that are participating in interaction. They come together, and then that hash that's been created, that goes on top of the chains that participated, and then those chains may never interact again. Kelly used the word diverge, and then they go off and they interact with everybody else. But that hash that we created in that block now proliferates throughout all the other chains in the system as they start to interact with each other. So we're getting to a secure, immutable place, but it's in a very different approach to what we see with the monolithic chains, where we're basically just looking at one Merkle tree that spans one central ledger. So that's how we're able to achieve this privacy and security that's in between or among the chains, rather than relying on something that has to be jerry-rigged for a public chain, as we see other approaches trying to do.
Fascinating. Yeah, no, that's super useful, and I think it really clears up some points. And that actually leads us to the audience question. And Kelly, you might be the best one to answer this. So the audience question is, MTX wrote, is IronWeave a good platform to tokenize real world assets? But feel free to
Yes.
angle in any direction.
I would love to address this. This is, I think, one of our strongest areas, is to kind of be the platform that can really bring to reality tokenization of real world assets. Because, I mean, there are ways you could accomplish it on other chains through the use of clever smart contracts and having then information ledgers and tracking movement of assets and basically treating them like an NFT in a smart contract marketplace. But there are better ways to do this, and to be able to actually look better at the history of it without having to scan, you know, and look at event tracking. And so, because we can create a chain for anything, and we can have an unlimited number of chains, and those chains can be passive chains. They don't have to be chains that author blocks. They can just be chains that are included on blocks. So let's look at, for example, a house, right? Here's the ultimate real world asset, property, right? There's a finite amount of it, and it changes hands these things change hands every day. So we could tokenize these, and I could tokenize property and create it. Not only do I have, on my chain, I can have a record that shows that I own that. Maybe then I'm interacting with the chain of the local county assessor to prove ownership there, where we've got an initial authority. We have to start somewhere. Eventually, this all becomes trustless. But right now, we live in a world of trust. So we say we use the county assessor's office as the local authority to establish that initial ownership. Well, that puts the genesis. But then I create a chain for this house. And if I later turn around and sell this house to Tim, right, not only is there an interaction on IronWeave between our two chains, but every time that house has changed hands, whether it's a house or a car, it goes on the house's chain. The house has its own chain that any given owner of it can follow. Same thing then, maintenance records I've done on that house. I have the roof replaced. I think my house is due for roof replacement in the next 5 years. Yeah. That goes on that chain. That can be authored by the company, a certified home repair company, right, that has on-chain tracking their certification from whoever's doing the certifying, right? They can make that information available to their chain, then they write on my chain that I've repaired the house. Now, when I'm going to sell this house to Tim I just give him the key to read the house's chain, let him read these. I share this information with him, make it verifiable to him, and he can see the maintenance records. He can see all this. I hand it over to him. Now he owns that chain because we can rotate keys. He can rotate the keys and control that. So because we have the data is private, but the data is also shareable, and that data can then be verified through, walking back the chain, clients can easily be built without needing complex interactions of smart contracts to tokenize real world assets. And platforms can be built all around this, backed by IronWeave, for tracking real world assets, whether it's houses, cars, etc., transactions of these things changing hands, maintenance records, updates, all these things that are residing in private databases where you're ultimately trying to trust an authority now. All of this could move into the ecosystem of IronWeave with the scale and privacy and shareability of the data.
Interesting. So basically, with all the interactions remaining private until I share my chain or Tim share his chain, so it's fascinating. And I think I don't
have to share a whole chain. I can share just a selection of blocks.
Amazing. All right.
This also applies to, let's say, Wall Street as well. If you think about capital markets and what it is that the participants would like, they would like to interact with each other. They need scale. They need speed. They need to be able to know who their counterparty is, but they don't want everybody to know what assets they're holding, and they don't want everybody to know what strategies they're deploying. Right now, if you're using Ethereum or the public chains, all your assets are out there for everybody to see. You can see how assets are moving, trading strategies that are being employed, and it's just not realistic to think that the Goldman Sachs and the JP Morgans of the world are going to migrate to a system like that. So the same thing that Kelly was describing that can apply to residential homes or multifamily buildings or any other type of real estate can also apply to the broader capital markets, because it ticks the boxes that they need ticked in order to participate in this world.
Absolutely. And this actually kind of brings us to the next question, which is, where are you in development cycle? So what can you tell us about IronWeave? David? David, I guess, can start, and then Kelly jump in potentially.
Sure, I can just start by saying this is not just a PowerPoint vision. It's actually up and running in its alpha version today, thanks to Kelly and our development team's work.
No. Oh.
Yeah, thank you. Our version 1 has been up and running for over 2 years. We've had version 1 running. The version 2 alpha, which adds the DeFi capabilities. We started more in the data space, but adds the capabilities for DeFi. The version 2 alpha has been up and running for several months. And so really we're at the stage now of going in and raising capital to start building out the network.
It's fantastic. Yeah, and if let's say some like investors are watching this, or what would be the good way to contact you? Maybe Tim, you can address it. What would be the next step for them?
For investors who are interested, they can go to ironweave.io. And yes, we just kicked off the seed round about a month ago, and we're looking for capital that will help us get from where we are today with the alpha that's already been deployed. Utility patents have been issued for the architecture that Dave and Kelly have described. And our goal is to raise enough so that we can deploy the fabric ready for commercial applications, along with the first decentralized application, which we will build on top of that, which will be a messaging application, which will allow for private, secure, immutable messaging.
Fantastic. It also answers the timeline. So I had a question for that. So twofer. So I guess we'll jump into some audience questions in a bit as well. I think we already answered some of those, but I want to ask a big one. And what do you think is the biggest opportunity for crypto in the future, and that maybe how the IronWeave plays a role in it? So kind of what is your vision? What's your belief in it? And Dave, maybe we'll start with you, kind of give us your thoughts on it.
Sure. So in terms of the biggest opportunity, is that what you were saying, Art?
Yeah. What is biggest opportunity for crypto, and how does IronWeave would be playing a role in that?
Right. So I think the biggest opportunity for Web3 and crypto is enabling data to be on chain in a secure mechanism, in a secure and private way, but also to tap into the just vast industry of digital interactions and data for businesses and enterprises. So as Tim described, enterprises and traditional finance and other enterprises can't put data on a public blockchain that can be easily scanned. There are all sorts of interesting opportunities for programmable money, digital assets, et cetera. But the biggest creators of data are not here yet. We've just scratched the surface. And we believe that IronWeave, as a horizontally scalable solution that's private and secure, is going to grease the skids for a lot of data and a lot of enterprises and a lot of flow of capital to come into the Web3 space.
No, and that's very important. The capital, where this is kind of the Rubik's Cube. How do we solve that? A lot of capital flows from Web 2 to Web 3, and great to see that IronWeave looking at it. Kelly, maybe you jump in next on your vision.
Yeah, I think the biggest opportunity right now in the crypto space to me is to see crypto really start to actually take off in the world of commerce. People really buying and selling things other than, crypto focused assets like, NFTs, et cetera, with crypto. There's a little bit of it happening, but, I still can't buy off Amazon with crypto. I can't pay my land. I can't pay the handyman who comes and fix things that are broken at my house with crypto. And so getting it a little more ubiquitous, and the handyman or not, but be able to buy things online with crypto. And, one of the areas I think that kind of really helps, one of the original goals of crypto and the original, visionaries was to democratize access to capital and, get rid of a few central institutions controlling money. And we're seeing more and more cases where, Visa's deciding who does and does not get to conduct commerce. And I'm sure they have good reasons for the decision. I'm not going to go into any of that. I I prefer a world where we have electronic equivalents of cash that we can work with, where you have something you're presenting, it's provable. You have a network that facilitates the movement, the transactions are private, and anyone can set up an account and start sending and receiving. And that was really the vision for crypto when it started. But it's been out of reach for too many people. And again, the scalability and privacy issues have prevented it from really taking off in the e-commerce space. And so I think we can help get through that by making the transactions private and by making handling the scale necessary to compete with things like the Visa network. I think we can really help bring crypto to be significantly more mainstream in the terms of buying things online.
Yeah, absolutely.
I'd love to not have to pay 3% to a credit card company, or have someone paying 3% to a credit card company to have groceries delivered, or the tiramisu that I ordered my wife last night.
That's right. I'm sure she'll love it too. All right. It's Tim, maybe to tell us your vision, how you see how things being interconnected, and why do you think IronWeave can play a real critical role here?
Well, it gets back to what I described earlier. I think that having a decentralized platform which still allows people to maintain their privacy and to have security over their data opens up a whole world of possibilities across industries. So eventually, I see most data that's connected to the internet being held in IronWeave blocks, so that no longer do we have these horrendous hacks that we read about on a daily or weekly basis. Now, 23andMe was just hacked a few weeks ago. All of that information is now out there, and it's just too often that occurs. So I would love for this data to be better secured, for people to have control over their data and who gets to see it. And if they want to monetize it, they can monetize it. Then also allowing for this flow of assets on chain, so that we can finally realize the future, the promise of having programmable money, programmable assets, and really making the most of the wealth that people have, and doing so in a very dynamic way, in a programmatic way, so that as people's needs, as their desires evolve, so can the asset composition which they're holding and the people that they're interacting with. Our system finally allows for that vision. So I really think that is going to create a tremendous amount of value really across the world.
Absolutely. It's all about creating value in Web3. So it's really everything is done for that purpose. So great to see that IronWeave really, zeroing in on the problem. Let's take a few more questions from the audience. I think Marcos saw something. I guess so. Let's go with, are there validators on IronWeave? How does this work? Kelly, maybe you're more capable of answering that.
Sure. So there's actually a couple of different kinds of nodes in IronWeave. So one thing I'll say, without getting too far into this, is we believe that there is a distinct difference between people that want to interact with and use apps on chain and people that actually want to run nodes and participate. And in too many chains, in order to really succeed, like as an app developer or building an app working with the chain, you really need to run nodes and participate in the network. Or hire a professional staking firm, etc. So we've really separated these roles, and even within the network we have a couple different roles. So we have the manager nodes that handle the core consensus of the heads of chains on the network, and David alluded to those earlier. But those don't validate individual blocks. Those only validates updates to the head of the nodes. That controls the pointers to where the latest block is on every chain throughout the network. And whether or not a chain is locked for writing, allowing better management of the state machines. In addition to the manager nodes, we also have the compute and storage nodes that do most of the work of what you would call a traditional validator or verifier node in something like new Ethereum, or the miner nodes, if you will. And so those are the nodes that you're working with and you're submitting the transactions to validate the blocks, to validate the transactions. And the amount of work they do depends on what you're asking them to do. If you're just asking them to validate authorship of a block, maybe there's no asset or no provable asset moving, you're just transmitting data, like, for example, our secure communications application. The only thing they have to validate is that I properly authored the block. And so it's a very simple task for them in that, and that's done through a small consensus. So there's a form of dynamic partitioning on the network where small clusters are set to agree on, multiple parties confirming the same result in the blocks and publishing this out. I'm not going to get too deep into the weeds on the core of all the consensus and the multiple different layers of the consensus algorithms. But yes, there are validators that do the work. And when it comes to, the financial, yes, those validators will prove, for example, they will confirm through the algorithms that you did have the currency to send. If I'm sending Tim currency, if I'm sending him, crypto on chain, they will confirm that I didn't just make it up, that I had the currency to send.
Amazing. Yeah, and let's this one as we'll move to our last but not least question. What do you think this thing is the biggest challenge for crypto now? And I guess so let's start with I guess it was David, and we'll go around. So David, what's your, for that space in crypto, what would you really shift?
I would say the biggest challenge is privacy. So someone, not me, came up with this really easy handle for Web 1, Web 2, and Web 3. Web 1 was read-only. Web 2 was read-write. And Web 3 is read-write-own in terms of data. So for Web 3, in order for you to be able to own your data, it has to be yours and it has to be private and secure. Without privacy, there are so many things that you can't do in Web 3, and this log jam of intent and value to be unlocked once those floodgates of scale and privacy are open. So, and having the experience that I do in the enterprise space, the privacy and security are first orders of business for any sort of data, especially something that's online. So I'd say privacy.
Excellent. And Tim, do you want to tackle it as well?
Sure. I'd say that education and regulation are a couple of very big hurdles that the industry needs to get over. And frankly, I think that good regulation is a function of good education. So I think it really starts with education, helping people understand what these technologies are all about, what they can achieve, how they can address real world problems, and how that will impact people. I think once it's more clear to businesses, then more will gravitate to the technology. And when it's more clear to regulators, they'll develop more sensible regulations so that the industry can flourish the way that it should, to create the value that we all believe it can bring to humanity.
Amazing. And really massive opportunity here. Kelly, maybe you can close out with your view on what is the biggest challenge to crypto right now.
Misconceptions about how the networks actually work that make it very easy to write very easy to hack smart contracts. I'm going to give you the approach of a developer and a guy who spent the last 25 years in information security. Again, without going too far into the weeds, the dependence of most cryptocurrencies on smart contracts and open source smart contracts at that, some of the biggest thefts of value we've ever seen in the world have happened in the last 5 years on blockchains, right? I mean, from the original DAO hack that actually caused a hard fork of Ethereum, right, was caused by the misconception of a truly single-threaded state machine that isn't, and what in other programming languages we'd have called a race condition, but people in the Web3 world like to pretend doesn't exist, but they do. And so we've taken an approach in IronWeave to, one, you can have multiple currencies moving on IronWeave, native movement of any token without the need for smart contracts at all. The network just handles it. It's a first-class feature for any kind of token, any kind of crypto. You can still do smart contracts for it, but you don't need them. That also goes to a privacy aspect, but also certain things like, are the managers in our consensus enforcing locking to actually prevent the kind of situations that led to that massive DAO hack. So the same code wouldn't have been a bug in IronWeave. It wouldn't have necessarily been vulnerable to the same type of timing attack. And so it may not be the biggest problem facing, and it is certainly getting better every day, but I would say that some of the education and some of the misconception, especially by young developers who are excited about smart contracts and crypto and tokens and blockchain that don't really understand the underlying fundamentals well enough, it's just too easy to leave smart contracts vulnerable to attack and leave millions or billions of dollars up for grabs for a motivated hacker.
Yeah, it's an anecdotal experience. I was just looking on Twitter, somebody I follow. It's some known NFT guy, and he's like, I just got my atomic wallet hacked, and he says this is like I lost everything through hacks, and he just starts explaining 5 ways he lost Ethereum here, NFTs here, and every time it's a different vector of attack. So this time he's like, I don't even know, it was a wallet, it was cold storage. So to your point, very needed. I will. Okay, so there's a bonus question. All right, so I said the last question while I kidded. So there's one more question, and which is important for others. And will there be an IronWeave token, which is perfect ending for the session? I don't know who wants to.
We'll let Tim answer that.
Tim, all right, let's go.
We anticipate that there will be a need for a token or some way of paying fees on IronWeave. And this is something which probably will not be decided in the next couple of months, but certainly will be before we release IronWeave commercially in 12 months. So stay tuned.
Stay tuned. All right. So you heard it. You heard it from the horse's mouth, so they say, right? Stay tuned. Well, first of all, I would like to thank everyone here. Thank you for coming. To this panel, fireside chat, however you want to call it, really sharing your insights and thoughts, because I think a lot of people don't know how much cool technology out there being built, and I think IronWeave is really leading the pack in a way that this revolutionary technology can be integrated. So I'm thrilled that you were able to join us, and I'm sure it sounds like our audience had so many questions, so they're thrilled as well. So please join us at some point in the future, or at least bring me as a moderator. Happy to do it again. But yeah, it's like as somebody who's seen so many great projects and bad projects and sad projects, I think you guys really stand out as a really powerful, strong project with a lot of awesome ideas. And on this note, thanks everyone for coming, and we're going to be having more sessions from Blockchain NYC on various topics, but I'm sure stay tuned with IronWeave. I believe they share their Twitter here, so please check it out there, follow them, and you can find out more at ironweave.io. So thank you all, and have a good one.
Awesome. Thanks, Art.
Thanks, everyone.